In this video today, we're going to be looking at TollAnalyst, what it is, and how we can use it inside of SOLIDWORKS. So the first question, what is TollAnalyst? Now typically when you're working in SOLIDWORKS, you'd always make your models to the nominal sizes. Now, when you come to manufacture, whichever manufacturing technique you use, you'll then get a tolerance on that. So it might not be to the exact nominal size, you've created it inside of SOLIDWORKS. Now this means that when you actually come to assemble your finished model, it might not fit. You might find that the tolerance that's been stacked up through the components will either make it too big or too small, and you'll end up with a slight clearance issue. Take this example on screen at the minute. It's quite a simple red box with 3 components sitting inside of it. Now each component has got its nominal size, and then it's also got its tolerance. Now if each 3 of these components were at their maximum tolerance, what could happen is these could then be too large, and that would have a knock-on effect with component to component to component, and that could cause these 3 components to not fit inside the housing inside this red box. So what can we do about it inside of SOLIDWORKS? Now this is where the TollAnalyst comes in. The TollAnalyst will allow us to automatically calculate what the maximum and minimum limits are depending on what tolerancing data we've applied to our models. So let's go and apply this to an example. Now to start with, we're going to take you through 2 different examples. The first one being quite a simple sleeve. Now if I just quickly do a section view, we'll explain what we're going to do in this particular one. Now in this case, there's a small lip that joins these 2 components together. Now what I want to know is the tolerance gap from one end to another. Now at the minute, these have all been made to their nominal sizes. The way that the TollAnalyst is going to get the tolerance information is for using the DIM experts. Now within each one of these parts, DIM experts have been placed, and inside of these you've then got the tolerance we're going to use inside of the analysis. So for example, the length of this sleeve, 250 plus minus 0.5. The distance from the end to the inside lip, 50 plus minus 0.25. Okay, so both of these components have already been given DIM expert information. So the next step, once we've done that, is to actually go into our TollAnalyst. Now the TollAnalyst is an add-in, so to get it inside of SOLIDWORKS, you need to make sure it's been turned on. Once you've got it enabled, you can then access it through the DIM expert tab on the left-hand side. Now the first step is defining what distance we're measuring between. So in this case, it's going to be from one end of our sleeve to the next. Currently that's set to 350 millimeters. The next stage is we're going to choose how it's actually going to physically go through the assembly file. In this case, it's quite simple. It's just going to go from one to the next. But you might find that your tolerance stack up might consist of 5, 6, 7, 8 components, and it might have multiple routes. You might be able to go one way, and you might have a different tolerance stack up. You might be able to go a different direction, and again, get a completely different result. Now the next stage is the assembly constraints. Now with the TollAnalyst, it needs to know how we're going to get from one component to the next component, because the DIM expert information allows us to go through the parts, but to jump from part to part, we have to go in and use the mates. In this case, there's a coincident mate between the inside of the lip, between the sleeve and the other cylinder. So we're going to use that as our primary constraint. If we then hit next, we get to the results of our TollAnalyst. And in here, it goes in and it gives us the nominal size, which is again 350 mil. We get the minimum and the maximum. We also get the RSS min and max. If we scroll a little bit further down, we actually see how it's gone through the assembly file, which dimensions are actually being taken into account. So in this example, they use this beginning DIM expert for that internal sleeve, 200 plus minus 0.5. We then go to this width dimension, 250 plus minus 0.5, and then there's 2 more to go in and get from component A to component B. Now next to each one of these dimensions, we then have a percentage value. This is almost like a contributor value. The higher the percentage, the more that dimension is influencing our tolerance stack up. So in this case, this particular tolerance, width 1, is affecting it almost 30%, and you can see that they go down smaller and smaller as it goes. So you can see which dimensions are having the most influence on this particular tolerance stack. So you can see in this case, I'm pretty happy with the results, minimum and maximum, all within plus minus 1 mil. That's perfect, that's exactly what I want. So the last stage is to go in and export some results. Now what it'll do is it'll go and export these to an Excel spreadsheet, and it will, inside the report, it will then show us which dimensions we've used, what the minimum, maximum, RSS, min, maximum is, and it'll also show us which constraints we've used to get from one component to the next. Okay, let's go try a slightly more difficult example. So my next example is going to be this. It's a tool holder. So the purpose of it is there should be a tool piece that's going to sit in between this face here and this face here, and that's then going to hold it in position. And obviously if it's a tiny bit too small or too large, it's not going to hold it very well. Now just like before, the DIM expert information has already been applied. So if we just quickly open up one of these parts, you can see all of it has already gone in and been defined. So the toll analyst add-in is already turned on. So what we're going to do is we're going to jump into a new study. And this time around, we're going to measure it from the underside of this purple component to the top of the grey base, that dimension there. And that at the minute is 100 mil. So again, they've made this to nominal size inside of SOLIDWORKS. So picking our components, we're going to start at the base, that's going to be our base parts. We're then going to go to the orange riser at the back, and then into the actual holder, the purple holder at the top. That's going to be our last part. Okay, so dimensions. Now this time round, due to the way it's been mated, there's actually multiple dimensions to pick from. And depending which dimensions we choose will depend on how it transfers from part to part. In this case, there's actually a coincident mate with the top of that grey face to the bottom of that orange riser. So we're going to use that coincident mate here. You can pick multiple mates. You have the option of picking 3 in total, and that will again affect the results. Okay, so there is from the first to the second components. The next, it's how it's going to be mated to the actual holder. So coming down here, we're going to choose our holder components. And there is a very slight lip there. And again, that's just a coincident mate, and we're going to use that for our analysis. So moving on to our results. Again, you can see the nominal size, 100 mil. The minimum and the maximum, 98.3, the max, 101.7. Now that range is a little bit too much for me. If I could, I actually want that to be a little bit tighter in terms of the tolerance stack up. Now, what we can do is, well, for starters, we could actually change the nominal size of our components. Just make them, either a little bit smaller or a little bit wider, depending which direction we wanted to go. We can also change what tolerance those values are using, so we could potentially manufacture it slightly differently, maybe use a different tool. Now in this case, let's go and change the tolerance of that top dimension here. Distance between 19 riser. That at the minute is 123 plus minus 0.05. Now if I double click on it, I can actually change what that tolerance value is. So rather than 0.5, I'm going to go for 0.25. Now in changing that will actually go in and affect the toll analyst. So what I'll need to do now is go in, recalculate it, And you'll see that the dimensions, the min and the max dimensions, have actually changed. It was 101.7 a second ago, already it's come down 101.45. Now what we could do is we could continue changing them until the min and the max, or even the RSS min and max, falls between the acceptable limits there.